Hello everyone and welcome back to JCE Connect. I am Professor Jotawar from Jain College of Engineering. Today we will continue with the first model of cloud computing. In the previous class we covered eras of computing, cloud computing at glance, and the vision of cloud computing. Today let's continue with historical developments. Since the beginning, the technology has been evolved and refined many times. This process has created a series of favorable conditions and realization of cloud computing. The evolution of distributed computing technologies have influenced the cloud computing. There are basically 5 technologies: distributed systems, virtualization, Web 2.0, service-oriented computing, and utility-oriented computing. Distributed systems. Clouds are essentially a large distributed computing facilities that make available their services to the third parties on demand. That is, they provide services. They provide services to the users. Now, as the definition goes, a distributed system is a collection of independent computers that appears to its users as a single coherent systems. What does this mean? Now, systems or distributed systems can be also understood as systems or computer systems can be located at different places with different configurations or their own um, types of different systems. All these are being connected with each other through a network, but performing as a single system. That's what it makes it unique. That is distributed system. This is nothing but can also be understood in the form of cloud. That is, clouds are also nothing but large distributed systems, you can say. Clouds are essentially large distributed computing facilities that make available the services to the third parties on demand. For example, whenever we need services, we can rent them, we can buy them, we can buy them, or we can rent them, we can use the services as per our demand. It evidences two very important elements characterizing the distributed system. First one, the fact that it is composed of multiple independent components, and that these components are perceived as a single entity by the users. This is practically true in the case of cloud computing, in which sorry, in which clouds hide the complex architecture they rely on and provide a single interface to its users. The primary purpose of a distributed system is to share resources and utilize it better. This is true in the case of cloud computing, where this concept is being taken to extreme, and resources such as infrastructure, runtime environments, and services are rented to the users. One of the driving factors of cloud computing has been the availability of the large computing facilities of IT giants such as Amazon and Google, who found that offering their computing capabilities as a service provided opportunities to the better utilization of their infrastructure. Distributed systems often exhibit other properties such as heterogeneity, openness, scalability, transparency, concurrency, and many more. To some extent, these also characterize cloud, especially in the context of scalability, concurrency, and continuous availability. There are three major milestones that have led to cloud computing. They are mainframe computing, cluster computing, and grid computing. Mainframe computing. These are the computers that are used or primarily used by the large organization for critical applications. For example, processing of bulk data such as census, industry and customer statistics, enterprise resource planning, and transaction processing. Cluster computing, or also known as high performance computing frameworks, is a form of computing in which bunch of computers, often called as nodes, that are connected through a network so that they behave like a single system or single machine. Third one is a grid computing. Grid computing is a group of computers physically connected over network or internet to perform the dedicated task together, such as analyzing e-commerce data and solve complex problems. Grid are form of super virtual computers that solve particular applications. Grid size may vary from small to an enterprise network. Next one, we have virtualization. Now, what is this virtualization? We often get this question, what exactly is this virtualization? given that we use this virtualization every day when we access the cloud or cloud services. Today's computers has tons and tons of processing powers, including fast CPU processors, fast CPU speed, fast RAM that's inexpensive, and tons of storage capacity. But is this computing power being used efficiently? Unfortunately, the answer is no. When the hardware and the processing power is underutilized and the electricity is wasted, no other in other words, resources are wasted. Virtualization helps to solve the problem of underutilized resources by creating a virtualization layer between the hardware components and the users. This enables the creation of virtual machines, which are virtual computers that can run in multiple numbers on a single set of hardware. The virtualization layer creates a virtual hardware components for the virtualization layer creates a virtual hardware components for the virtual machines, also called as VMs. Here you can see virtual machines or virtual computers needs all the same components that a regular system needs. For example, it needs storage, it needs network interface cards, that is NICs, it needs processing, and it needs RAM. Virtualization takes these physical resources and turns them into virtual resources for virtual machines. Now, all this virtualization is nothing but kind of creating a effect, or rather making you believe that it is existing. You can create multiple number of systems or multiple number of operating systems on a single system by using this virtualization. For example, you might have came across something called as VMware software. What it does, it basically creates a layer or a platform on which you can install multiple number of operating systems wherein they work as an individual system, like they are physically or actually present there, but they are not, they are physically present. They are utilizing all the hardware components or the physically existing hardware components of your system and giving you results. What it is doing is, it is providing a platform on which you can install that entire operating system. For that operating system, it needs RAM, it needs processor, it needs storage. Basically it needs these three. Apart from this, there are other components as well which also been utilized from the same system, but these are the basic these three. But is that virtualization or is that operating system getting those physically? No. Whereas this virtualization is creating a delusion for that operating system that it is existing, but whereas it is using the same computation power from the existing system, that is your physical system, and creating those virtual machines. You can create n number of virtual machines on a single system. Where, for example, let's say you are setting up a new lab, and let's say there are about 10 systems. You want you are installing on one single system. You have installed n number of softwares with different settings. You have created one perfect system for yourself, and you want to do same for the rest of the 9 systems. For creating a single system, it took you, let's say, about 4 or 5 hours. Now think that doing the same for all those 9 systems, it is tedious. It takes days together, at least 2 days in the minimum. Best thing what you can do is, you can replicate this. You can create an image copy of your existing system. Whatever you created in the first system, you can take an image copy of it. You can replicate those images or those operating systems on the other systems. It will hardly take half an hour or so. So within no time, you have created a number of systems. Now these are single systems. Creating them virtually will give you more. No, as the further about it we will be learning in the further chapters. Now apart from this, there are a number of advantages of virtualization as well, that is increased efficiency and multitasking, because you can run multiple computers instead of just running a single computer on your computer hardware. You can run multiple operating systems on multiple computers on a single set of hardware. It can also increase the manageability or ability to move, copy, or isolate the virtual machines. Increased sustainability, with increased energy saving by usage of less hardware and electricity. Increased availability, with the ability of snapshot virtual machines, clone them, and run redundant virtual machines. Increased security by isolating virtual machines from one another and isolating them from actual or course system, as well as isolating applications and the ability to run legacy applications that won't be possible sometimes on a regular computer. Next we have Web 2.0. The web is the primary interface through which cloud computing delivers its services. At present, web encompasses a set of technologies that facilitate interactive information sharing, collaboration, user-centered design, and application composition. This evolution has transformed the web into a rich platform for application development and is known as Web 2.0. Web 2.0 brings interactivity and flexibility into web pages, providing enhanced user experience by gaining web-based access to all the functions that are normally found in the desktop applications. These applications are obtained by integrating a collection of standard and technologies such as XML, Ajax, web services, and others. Web 2.0 applications are extremely dynamic. They improve continuously, and new updates and features are integrated at a constant rate by following the usage trend of the community. Lightweight deployment and programming models are very important for effective support of such dynamism. Loose coupling is another fundamental property. New applications can be synthesized simply by composing existing services and integrating them, thus providing an added value. Web 2.0 applications aim to leverage the long tail of internet users by making them available to everyone in terms of their media accessibility and affordability. Examples of Web 2.0 are Google Documents, Google Maps, Flickr, Facebook, Twitter, YouTube, Blogger, Wikipedia, and many more. In particular, social networking websites have take the biggest advantage of Web 2.0. Next one, we have service-oriented computing. Service orientation is a core reference model for cloud computing systems. This approach adopts the concept of services as the main building block of applications and system development. Service-oriented computing supports the development of rapid, low-cost, flexible, interportable applications and systems. A service is an abstraction representing a self-describing platform skeptic component that can perform any function, anything from simple function to a complex business process. A service is supposed to be loosely coupled, reusable, programming language independent, and location transparent. Loose coupling allows services to serve different scenarios more easily and makes them reusable. Services are composed and aggregated into service-oriented architecture, which is a logical way of organizing software systems to provide end users or other entities distributed over network with services through published and discoverable interfaces. Software-oriented computing introduces and diffuses two important concepts which are also fundamental to cloud computing. First one, quality of service and software as a service. Quality of service identifies a set of functional and non-functional attributes that can be used to evaluate the behavior of a service from different perspectives. These could be performance matrices such as response time or security attributes, transactional integrity, reliability, scalability, and availability. Quality of services requirements are established between the client and the provider, that is service provider, via service level agreement, also known as SLAs, that identifies the minimum values or an acceptable range for the quality of service attributes that need to be satisfied upon the service call. Next is software as a service. It's a software distribution model in which third-party provider hosts applications and makes them available to the customer over the internet. The term has inherited from application service provider, which deliver the software services based solutions across the wide area network and make them available on subscription or rental basis. The application service provider is responsible for maintaining the infrastructure and making available the applications, and the client is free of maintenance costs and difficult upgrades. Next we have utility-oriented computing. Utility computing is a vision of computing that defines service provisioning model for compute services in which resources such as storage, compute power, applications, and infrastructure packed and offered on pay-per-use basis. The business model introduced with utility computing brought new requirements and led to improvements in mainframe technology. Additional features such as operating systems, process control, and user metering facilities. Computational science, which was one of the major driving factors for building computing clusters, still required huge compute power for addressing grand challenge problems, and not all institutions were able to satisfy their computing needs internally. The capillary diffusion of internet and web provided the technological means to realize the utility computing in the worldwide scale through a simple interface. Computing grids brought the concept of utility computing to a new level, that is market orientation. With utility computing accessible on the wider scale, it is easier to provide a trading infrastructure where grid products, storage, computation, and services are bid for sold. Moreover, e-commerce technologies provided the infrastructure support for utility computing. From an application and system development perspective, service-oriented computing and service-oriented architecture introduced the idea of leveraging external services for performing specific tasks within a software system. Applications are not only distributed, they started to be composed as a set of mesh of services provided by different entities. These services are accessible through the internet, were made available by changing according to the usage. Thank you.